Hi guys, I'm giving you a quick lesson on matrices, and then you're going to do a few problems from the classwork, and then that's it, no homework. So introducing matrices. Matrices kind of look like these arrays right here, and they're defined by rows and columns. So this particular matrix has 2 rows and 3 columns. Okay, rows go sideways and columns go down. And we would say that the dimensions of this matrix, dimensions of matrix A here are 2 by 3. Typically, we use capital letters to define a matrix. And then when we're talking about individual entries here, we use the lowercase letter associated with that. I'll show you what I mean. But when you say the dimensions, you always say the number of rows first by the number of columns. Okay, so this is a 2 by 3. Always rows come first. That's the convention. So here, if I'm talking about little a and I put 2, 3, what that means is the entry that's in the second row and in the third column, and that would be the 9 right here. So a sub 2, 3 is equal to 9. Okay, sometimes you see it with a comma here and sometimes you don't. But that would be how you refer to the matrix. If this were matrix C, this would be like right here, this would be C, comma, 2, 1. Okay. And then we also have operations and algebra associated with matrices. So this A and with a little t that looks like it's sitting in an exponent almost, A with a t up here means A transpose, and that's when you swap the rows and the columns of the matrix. So if I'm going to find A transpose for this particular matrix, what was the first row becomes the first column. So 2, 3, -4, 2, 3, -4. What's the second row becomes the second column. Okay. And sometimes you work with the transpose when you're performing operations, depending on what it is you are trying to do. So that's the basics of matrices. Here's an example of a 1 by 5, 3, 2, 6, 9, 0. This is one row, 5 columns. Okay, so operations. Basic operations are, as you probably think they would be, you can only add matrices that have the same dimensions. So if I have matrix A that's a 2 by 3, and I'm adding matrix B would also have to be a 2 by 3. And what you do is you add corresponding entries here. So if I were going to find A plus B, it would be 2 plus 3 is 5, 3 plus 6 is 9, -4 and -2. 1 and 0, 6 and 4, okay, that's 1, 9 and 1, which is 10. So you still end up with another 2 by 3. And then there's a notion of scalar multiplication. That language should remind you of vectors, because when we're working with matrices, you are actually working with vectors. This would be like the vector 2, 1, 3, 6, -4, 9. Those are called column vectors. We also have row vectors here, 2, 3, -4. Those have 3 components, 1, 6, 9. So these here are row vectors right here. And you can have vectors of, as you can see, the components can have any number of dimensions. When you do scalar multiplication, as we did with vectors, for example, k times matrix A means that I'm taking every element in matrix A and multiplying it by k. So here's an example of 3 times matrix A. I took every element in here and I multiplied it by 3. Okay, I want to show you on the calculator how to put matrices in, and you should pause the video and you should get your calculator out and follow along. Okay, so you'll see that you have the possibility of entering matrices. Mine is in blue sitting right here. So I'm just going to go to matrix, okay, second matrix, and you'll see there's matrix A, B, C, etc. And you can store matrices in here. So if I want to edit matrix A, I'm going to go over to edit, and then I'm going to select matrix A, which is the first one. And then you can use the arrows to change the dimensions and then put in the entries with the arrows. I've already done that with this particular matrix, so you can see that. And then if you are going to put in matrix B, second matrix goes to back to that menu. I'm going to go edit matrix B. I made it a 2x3, and then I put in those entries here again. This was my matrix B up here. Now I'm going to quit out. So second mode for me is quit. And I'm going to go grab those matrices. So second matrix, grab matrix A with an enter plus. Okay, and I'm going to add matrix B. So I'm going to go grab matrix B and enter, and there's the sum of matrix A and matrix B. And I can also store that in a new matrix, which you're going to want to be able to do. So whatever calculator you have, however you store it, it's probably using the same buttons. I'm going to go to store, and then I'm going to go grab, when I went to second matrix, another matrix here, let's say matrix C, and it stores it in matrix C. So now whenever I look at matrix C, it's going to give me that back. Okay, there it is. So you can do scalar multiplication. There's all kinds of operations that you guys are going to learn with matrices. You can also see, I can take, for example, matrix A, go to matrix again, go to math, and here are some of the operations that you can perform. So here's the transpose, for example. Okay, and there might be, maybe you want to end up storing that for whatever reason. So that's the quick lesson. And in class, I want you to do pages 2, 3, and 4, the problems. Those are classwork problems. Do all of the problems there. It's just giving you practice with notation. And then page 5, just do problems 1 and 2. There's no homework. This is just a very brief, quick introduction to matrices.